So the setup is as per the diagram, where we have sodium sulfite into a round bottomed flask, where you run down dilute hydrochloric acid. Then when the gas is produced, sulfur 4 oxide, since you may need it dry, you dry it by passing it through jar that contains can also be prepared by the action of concentrated sulfuric 6 acid on copper tannings. And the setup is similar to the one that we have looked at, save for the fact that you put the copper tannings in the round bottomed flask and you run down concentrated sulfuric 6 acid. You are also, it is of referring to it as sulfuric 4 acid. Then we look at the next reaction, because the reaction must take place in the presence of water. So we have now sulfuric 4 acid plus the dye to give us sulfuric 6 acid, He2SO4, plus colorless compound. So the oxygen from the dye is removed by the sulfuric 4 acid and it leaves it colorless compound. It leaves it a colorless compound. But this color may be restored if the bleached items are exposed to air for a long time. So we have allotrop A and allotrop B. Then we can see that above 96 degrees you get allotrop B. Below 96 degrees you get allotrop A. Purple to colorless. So we see the equation. The purple permanganate ion plus the sulfur in solution to give us a manganese 2 ion and the sulfate. The manganese 2 ion is colorless, and that is why the color is changing from purple to colorless by Frasch process. And we have concentric pipes. The middle pipe is M, the outermost is P, and the one in the middle, the center one, is N. A white precipitate is formed, and this confirms presence of the sulfate ion. The reason is, when you add barium ions and they combine with the sulfate ion, they form insoluble barium sulfate, which is insoluble and it is white. So that confirms that indeed inside the test tube there was sulfate ion. Burns in oxygen with a blue flame. It forms sulfur 4 oxide with traces of sulfur 6 oxide, that is SO3. The gases have a choking, irritating smell. That is why it does not change to vapor. Hot compressed air is pushed down the innermost pipe. The hot molten sulfur and the water are forced up the middle pipe, and the sulfur is collected in large and air coming to the burners. That gives or that provides sulfur 4 oxide. Then it is taken through the dryer and cleaners. That is sulfur 4 oxide. And then through the heat exchanger to increase the temperature. Now we have the sulfur 4 oxide gas and air going into the catalytic chamber where sulfur 6 oxide gas is produced. Again, it is passed through the heat exchanger so that the temperature can be lowered so that it can continue in the process. And then it is taken to the absorption tower, as we can see, where it is flowing, the gas is flowing into the chamber, and then there's a shower of concentrated sulfuric 6 acid. This gives urea, The oleum is taken to the dilution chamber where water is added. And when water is added, then you have the dilute sulfuric 6 acid.